Another category of indeterminate forms is when we have an indeterminate difference. That would be an infinity minus infinity form. That is also something indeterminate. So for example, suppose we had the limit as x goes to pi over 2 of secant x minus tangent x. And the problem with this is, of course, that the limit as x goes to pi over 2 of just secant x by itself is infinity. The limit as x goes to pi over 2 of just tangent x by itself is infinity. And so what we have is an infinity minus infinity. So we need to do some rewriting and reconfiguring of this in order to express it as a ratio, either a 0 over 0 or an infinity over infinity. Well, fortunately, with trig functions, there's all kinds of ways to relate one function to another. In particular, we can write secant as 1 over cosine x. We can write tangent as sine over cosine x. Combine the fractions. And then we get the fraction 1 minus sine x over cosine x. And of course, the top, as x goes to pi over 2, sine x approaches 1, so we get 1 minus 1, which is 0. We get 0 in the numerator. And the limit of cosine as x approaches pi over 2 is also 0. So now we have a genuine 0 over 0 form. Now we are allowed to apply L'Hopital's rule. L'Hopital's rule tells us we can evaluate this limit by taking the derivative separately of the numerator and the denominator. Derivative of the numerator is negative cosine x. Derivative of the denominator is negative sine x. Well, now we can just plug right in. When we plug into cosine x, we get 0. When we plug into sine x, we get 1. So what we get is negative 0 over negative 1, and this, of course, is just 0. And that is the limit. Number 2, we also have an indeterminate form of the form 0, infinity minus infinity, because of course as x goes to infinity, x itself becomes infinity, and the square root of x squared minus 1 also goes to infinity. Well, here, as you might suspect from our work with limits, what we're going to do is just multiply by the conjugate in the numerator and the denominator. So we're going to multiply by x plus x squared minus 1 over x plus x squared minus 1. Well, this is going to be the limit as x goes to infinity of, in the numerator we get the difference of two squares, so that's an x squared minus an x squared minus 1 over this sum in the denominator. Limit as x goes to infinity. Well, this one, as it turns out, we don't even need L'Hopital's rule. It would be a mistake to use L'Hopital's rule. In fact, just with this one was just the laws of limits. We can evaluate the infinite difference because right now we see what we have as a fraction where the numerator is 1 and the denominator is going to infinity. And of course 1 over infinity, that is 0. So we can take that limit without even use of L'Hopital's rule. Remember, you only use L'Hopital's rule when you have a ratio of 0 over 0 or infinity over infinity.